Good afternoon and welcome to the Andy Show. The day is 29th of June 2020. We're nearly done with June. It's a Monday. Time is coming up to 12:31. Well, data. Data. It's such an important thing, and it's been such an important thing during this lockdown. Data analysis for the pandemic and data analysis for the economy and so many different things. And we've spoken to a few different scientists on the Andy Show recently around about different types of data. But this guest is incredibly special. We are delighted to be joined by Dr. Alexander Jarasche, the head of Data and Knowledge Management Department at the German Center for Diabetes Research, the DZD, the Federal Republic's main center for long-term research on that condition. Dr. Jarasche is also a leading member of the COVID Graph Project, a non-profit collaboration of researchers, software developers, data science, and medical professionals who have built a research and communications platform that encompasses over 51,000 publications, patients, clinical trials, drug targets, case statistics, genes and functions, molecular data, and much more. There's a lot. Dr. Jarasche, welcome to the Andy Show.
Thank you for having me. Welcome to everybody. Super nice to be here. Really appreciate the invitation.
Okay, so let's start at the beginning. I've given you my intro spiel, but I don't think I can do as much justice as you can. Can you tell me a little bit about yourself, about what you do, and how you got into this?
Yeah, sure. So maybe a little bit to my background. I studied bioinformatics here in Munich in Germany. Also did my PhD here in biochemistry and structural bioinformatics. And then I went to pharma industry and to the chemical industry to be a consultant for some time. I created some machine learning algorithms and 3D modeling. And since 2017, I'm at the German Center for Diabetes Research, and I'm heading the Department for Data and Knowledge Management. And what we do is we organize, we structure, and we gather information concerning diabetes, the cause of diabetes. We try to understand diabetes, prevent it, and give people hope and hopefully support them in terms of their diseases and the following complications.
And that's fantastic. And if I understand your project correctly, your goal is to help research to quickly and effectively find a way through the COVID-19 data sets that you're obviously working on, and provide tools that use AI, advanced visualization techniques, and intuitive user interfaces. Is that a fair assessment?
Exactly. So one thing is the data itself. You have to structure the data. You have to connect the data, make it available, searchable, and then in the end present it to the researchers via a user interface. And this is what we're doing in the COVID Graph project, as well as in the DCD for some other projects. So this is our main goal. Exactly. We support researchers mainly.
And so data science, so it's quite a leap. Well, I think it's a leap. Maybe it's not a leap between medical science and data science. I mean, did you find that transition? I mean, was it part and parcel of what you were doing anyway?
Yeah, I really like the mixture of being at the border of the data science, so help people to understand data sets, to analyze them, but also to provide them with infrastructure, with more sophisticated algorithms, more sophisticated databases like graph databases, and in the end, being one piece of the puzzle, and enabling our scientists to have some new insights.
Well, and one of the things I was reading about that you'd done is you used the Neo4j graph database at DZD. I mean, how did you end up? First of all, what is that for anyone who's unaware? How did you land up using it, and why did you think it would help the organization?
Yeah, it's a really good question. When I started at the DCD, my task was to structure and to bring together all the information, so data sets that we have within our organization, because we have so many different data sets and so many different researchers, which are in the DCD, roughly 500 researchers, and you want to provide a data resource where they can browse what do we have, what can we combine, and then I came across Neo4j as a graph technology. And I thought, wow, this is really cool use case with some of my colleagues. And can I use that for solving my problem, to provide metadata and to make data searchable? And it was really easy. And I was super amazed. And now I'm a big graph enthusiast, and I really like working with Neo4j. For the people that do not know graph technology, a graph is a mathematical thing, and is a set of nodes that are connected by edges. And you can think about it like a network that you have, that your data is represented in nodes, and they are connected. For example, for people that we are connected, or other things in biology, they are connected anyway.
I mean, it's fascinating. So did you see an immediate benefit from using this within the organization? Was it just like an overnight success?
Yes, definitely. This is I would say, a game changer. Because in biology, in disease research, in translational research, everything is connected, right? You can imagine that a diet affects your health, or a certain environmentally a feature is also dependent on your health, or the other way around, that one disease is connected by COVID-19. Because the question, what is COVID? We see that diabetic patients have a severe risk of getting infected, and have a higher risk to die. So the question is why? But obviously something is connected between the two diseases. So it makes much sense to use a native graph technology to tackle that problem.
And did this lead on to something you've developed, COVID graph? Can you tell us a bit about that and how that started out?
Yeah, exactly. In many cases, our researchers ask me, did you read about this paper and that paper, and have you read about this or that? And usually, when you talk to 500 researchers, you cannot follow everybody, and you don't know more about a disease than they do, because they are specialists. And that brought me to the idea of automatically understanding literature and scientific publications, and maybe patents, and connected to the entities of biology, being genes, proteins, and their functions. And this is where we started at the DZD to connect this information together, so that other researchers can also benefit from this knowledge. And we started this so 1.5 years ago in the DZD, and then at the COVID crisis, we thought maybe we can provide researchers a data source where they can easily understand and connect different insights and results from COVID-19 related research.
I mean, it's fascinating. Just briefly before I start talking about what the actual outcome of this is, why did you use knowledge graphs?
I would say graph technology, as we talked about it, is very, very a game changer in that field, because it's natively connecting data. Why do we use knowledge graphs? Because we have so much data out there, especially in the public research sector, where we have publications, and these are insights that everybody uses or is available to everybody, but you have to bring it together. Especially if you think about disease areas. You want to bring knowledge together that is connected anyway. And usually these are stored in data silos, and we try to connect these data silos. And I would say the word knowledge is more like connecting the insights from different disciplines.
Well, I mean, you've done all the hard work in the research on how to build it, but what actual outcome are you trying to achieve from this? What are you actually trying to achieve? I mean, are you trying to find a cure for COVID? Well, what's the the purpose of it?
Yeah. Let's say on a long-term vision, we would like to contribute to a cure or to find a vaccine or a vaccination or a technique or whatever. But let's go back to the very beginning. This also everything is based on data and insights, and so we are really good in data integration, data structuring, connecting data. From a technical point of view, but also from a context view and from expert knowledge. And this is where we can support other researchers that do not have the time to spend their resources on data integration or on searching. And this is where we come in and support them, enabling them to use techniques like artificial intelligence or machine learning techniques. For these kind of methods, you have to have a certain data integrated and being connected. So data integration is our first and main goal. And as I said our vision would be to participate on a cure, but I guess we are more on the beginning of this problem.
It's fascinating. One of the things that piqued my interest from my own selfish geeky point of view is you mentioned that some researchers are using it for AI. Can you tell us a bit about the AI parts of it? Because I'm curious.
Yes, a little bit. Even if I don't like but it's really important. And I guess in AI researchers and AI people, they usually spend their time of cleaning the data, getting the data, search for data, and we try to help them. We also use some kind of AI techniques like natural language processing or finding more central cores or more central nodes in our big graph. We try to find communities. When we talk about patients' data, you try to find subgroups of people that have more in common within the cluster than compared to other clusters. So there are many really, really interesting use cases where AI can be applied.
Okay. You mentioned researchers and various different bodies that are benefiting from this, but at the moment, who is the project helping most right now?
Yeah, this is one of the parts I really love to talk about. It's an extremely amazing team that came together in early March this year. And we were some researchers from the DZD and some people that are collaborating with us. And as I said, we had some ideas from the DZD and applying these on the COVID story. And within 1 or 2 weeks, we had 20 developers and 20 very, very different people from other disciplines helping us, bringing in their knowledge, bringing their expertises, also people from the graph community. And now we are a really cool team of roughly 20-25 people working together on a non-profit basis, and this is the main core of the team. Data scientists and some researchers, some medical doctors.
It's amazing the achievements you've made in such a short space of time since this all started. All right, going back into the geekier side of this, what data sets do you use?
There's a variety of data sources that we integrated so far. In March, we started with a challenge provided by the Paul Allen Institute for Artificial Intelligence, and they gathered roughly 40,000 scientific publications from preprint servers together, and the challenge was to structure them, to make them available to researchers. And this was the beginning. And what we have are scientific insights from literature that you have to usually read, and you would agree that nobody's going to ever read 40,000 publications, and secondly to understand them. So it was a challenge already to structure them, to make them available, to pre-analyze them for researchers. And then we came to the very similar idea to understand patent texts where other coronaviruses, like the SARS virus from 10 years back, there were already insights. There were insights for vaccinations and for shields protecting your face and stuff like that. So there's also a source of literature data that can be connected and that people can learn from it. And as I said, since this is related to our prior work at the DZD, we connected this with experimental data from human, from animal data. And bringing that together, we have now experimental data from genes, proteins, their functions, in which molecular pathways they are active. We integrated clinical trial information. We recently integrated drugs and drugs targets, but also the case numbers from Johns Hopkins University and from the United Nations. We have let's say a pre-release from some press releases of clinical studies. So quite a variety of different data sources that are connected, that are all connected with each other, so that people can search for it from wherever they want to start. So yeah, it's open to everybody. It's non-profit. Everybody can use it for free. And
so you spoke about coronavirus, you spoke about the medications, treatments, existing treatments, drug trials, patents, papers. But what are the tools, just on a higher level, what are the tools that you're actually developing to explore these things?
Yeah, it's a good question. So one thing is the variety of siloed data and siloed insights. This is now a really nice pipeline that you can easily load different data sets together and connect them. So the question is now how to connect them, and this is where we use some machine learning techniques or artificial intelligence techniques like natural language processing. We try to automatically understand what's going on in the text, so context specific. We do named entity recognition. So think about genes or diseases or symptoms or dosages. You automatically have to recognize them in the text so that you can provide them to a user to search them. Another example is to use, it's called the Graph Data Science Library by Neo4j. They are providing algorithms that are based on graph data models. For example, we try to find very central points that are super connected with other entities. And the question is why they are such super hubs. Is that an interesting data point? We have one example for that already. We found out that one gene called ACE2 is highly connected and mentioned most in many different publications. And when you have a look into other databases to find information about this ACE2 gene, you will find that this is the main receptor where the coronavirus docks on and enters the cell. So it makes much sense to study this receptor. We also found out that out of our 55 different human tissues that we have data for in our database, that in 53 of them, so over 95% of them, this ACE2 receptor is active. And I would say this makes clear that COVID-19 is not just a lung disease or not just an easy disease that we can tackle. It's more complex than we thought.
It's I mean it's absolutely fascinating. So you've got the COVID Graph project. What is your goal for the applications that you will be providing?
Yeah, so one thing is having fancy algorithms and fancy computer science stuff, but you need to develop something for the users, right? And our users and the main people doing the research, they are non-computer scientists. What we try to achieve is build a really nice and easy to handle application for the users because they don't want to deal with nitty-gritty details in computer science, right? And when we talk about the applications, we want to provide a user interface that is interactive. And this is where graph databases and their applications come how do you say, come to play. Usually you have a query from your data, and as a researcher, you query a database for a specific result, and usually this is the end. Or if you do an analysis in your Excel sheet, usually you have your result, and this is more like static. With graph technology, or with our application, this result is just the beginning of your next data analysis, because it's an interactive result that you can move around. You can click on the data spots on the nodes. You can expand them. You can hide them. You can ask the question. So what is connected to this data point? Are two nodes connected at all? So this is very important for me and our users to have that as an interactive application. Yeah.
I'm going to ask you quickly about the technology behind all this, because obviously you're churning data, and it's going to take a lot of what we call a grunt processing power. I mean, how did you gather all that processing power together so quickly in such a short space of time?
Yeah, good question. I think it's a mixture between really, really good people at the team that are really doing hard work. But on the other hand, we have a technique, with graph technology, with Neo4j, to easily integrate data, to easily explain data. And since the data model, as a user would draw it on a whiteboard, is the same as it is in the database. And this makes life so easy, so scalable, and so flexible that you can easily adapt it. You can easily scale up. Actually, it's not we don't have so much computing power, so we don't need it yet. We have roughly 25 million data nodes inside and 50 million edges, and it's running on a 16 core machine, so it's not that fancy. I guess the technique makes a big difference, and the flexibility of it.
Yeah, no, it sounds like an incredibly complicated machine that you've put together to do all this. Okay, so let's talk brass tacks here. If you're now, we obviously hope you're successful with your data and what you're producing and the outcomes of this. But if you're successful, again, fingers crossed, COVID Graph could provide the databases for understanding the process involved in a coronavirus infection. But what have you learned so far?
I think we learned that most of the data is siloed, and that we have to reconnect it, because in many people's mind, data is already connected. So why is it siloed in different databases? So we have to bring it together. We have to bring it back together. Second learning for me personally is that graph technology is a game changer for today and for the upcoming years. I guess many companies, many researchers will realize that getting back these connections and making hidden connections available or searchable makes a big difference. And this is also the basis for more sophisticated algorithms that we use to analyze data to get new insights. So these are the main take-home messages, I guess, for me, and maybe for other interested people. Getting the data connected, working with connected data, and working with the users. And there is no difference between a user question and a question that I, as a computer scientist, have. So this makes a big difference.
Okay, so I'm going to ask the question that's probably on everyone's mind. Next year, will we all be back to normal? Is it going to take longer? What's your insight into it?
Very, very complicated. Maybe the most complicated question you asked so far. I guess it will be, still challenging. I don't know. So I guess the situation will be the same until we have a drug or a vaccination. But until then, I guess we will have to stay calm and be patient, and do whatever we can to support getting a vaccine or a drug against it.
I mean, it's your insight's fascinating. I'm going to be watching your research with a magnifying glass.
Thank you very much.
Dr. Jarasche, do you have anything else you want to add to this? Any of your final thoughts around the project, what you've been trying to achieve, or what you hope to continue with, or people that you want to get involved?
Yeah. So first of all, thanks to the whole COVID Graph team, to all the companies that are involved, to all the employees that contributed to that. It's an amazing team. It's such a pleasure to work with them together, and I guess it's a good example that many companies and academia can work together and making a big thing out of how do you say. It's a very complex problem, and we only spent 5 weeks on that. So it's already amazing. I hope that many researchers will find the way to our resource. Go on https://covidgraph.org. Get in touch with us. You can also wish for some new use cases. We can support you with some techniques or some data sources that we can integrate. So we're happy to support everybody, and get in touch with us.
Please do. Well, Dr. Jarasche, I can't thank you enough for coming on today. It's been so insightful, and the work you're doing is absolutely fantastic, and I wish you all the luck in the future as well with it. It's some great stuff.
Thank you.
Thank you. That was Dr. Alexander Jarasche, the head of data management and knowledge management at the DZD, talking to us about the COVID Graph project, how data scientists are working together to find commonalities and trends. Some fantastic stuff. So please check it out. You have been watching The Andy Show. The time is coming up to 12:58 p.m. on the 29th of June, 2020. Don't forget to join us on weekdays on Disruptive Live, on LinkedIn, on Facebook, on Twitter, and on our website. But until tomorrow, I'll see you soon.